are going up tomorrow. So, yeah. So progress reports are tomorrow, and just so if you're looking for the grade you want, then make sure you get all your assignments in, and understand that it takes a day for the Canvas grades to be flipped into Infinite Campus. So your grades will be whatever you have. That's the smallest ant. Oh my gosh, these are tiny ants. This is not good. I don't like these ants. So it takes a day for your grade to get moved from Canvas to Infinite Campus, which means whatever you have tonight at like 1 o'clock, whenever they do the grade flip, that will be what your progress report will be. Meaning, if you try to turn something in tomorrow morning, it's not going to matter. Okay, so that being said, you did have the ions and isotopes worksheet to work on last night, along with the lab. I've graded a handful of labs that are coming in, which is great. Today we're talking about half-life. And like I said briefly yesterday, or day before yesterday, half-life is the amount of time it takes something to decay into half of its original form. So far, so good. We have a lab tomorrow on Skittles, and I had to portion them out yesterday. I put them into a container and put them as far away from the ants as I could think of. So far, no ants in the Skittles, so that's good. If you have diabetes, just realize we're using candy tomorrow. So if you're trying to keep your boyish figure, then realize we're using candy tomorrow. All right, so half-life. So half-life is simply the time required for half a radioactive sample to decay. So the time for 100 grams to become 50 grams, or 1,000 grams to become 500 grams. Now, what happens to that material? Does it go away? No, it becomes something else. So one of the misconceptions is the idea that if you have 100 grams of uranium, after its half-life, you only have 50 grams of uranium and that's it. No, you have 50 grams of uranium and then 50 grams of whatever it converted into, alpha particles and whatever else. Does that idea make sense? So it doesn't mysteriously disappear, it just becomes something else. So uranium would become thorium or tactinium or something. So when you look at the half-life of a specific thing. So here's a good example. In a 100-gram sample of bismuth 210, again, 210 is the mass, bismuth is basically whatever the atomic number is, 83. In one half-life, 5 days, how much bismuth do you have left? You can blurt it out if you want. In one half-life, how much do you have left?
105.
No.
50.
50 grams, exactly. So you started with 100 grams, and in one half-life, which is 5 days, so if you had a 210, if you had bismuth 210, you had a 100-gram pile of it. You came back 5 days later, only 50 grams of that 100-gram pile is still bismuth. The rest is what? I'm sorry? Something else, yeah. In this case, it's thallium and alpha particles. The alpha particles have most likely turned into helium by now and floated away. So you have 50 grams of bismuth and then 50 grams of approximately thallium. Make sense? Okay. So go ahead and answer these 4 questions on your paper. So how much do you have in 2 half-lives, in 20 days, in 25 days, and 23 days? Give that a try. So, there is, what do you have for bismuth, and what do you have in thallium? How much? Again, we're going to ignore the mass of the uranium, of the alpha particles, because it's so small. So make a little table, and it's like after this half-life, or this time, you have this much bismuth and this much thallium. So do that right now. Troy, you can use the prototype. See, when you're working, and then when you're done working, you turn it to done. Okay, so right now you're working, and when you're done working, you turn it to done. Even sanitize it for you. I got you, sir. I think that's good enough. So in one half-life, we got 5 days have passed, and our 100 grams of bismuth has turned into 50 grams of bismuth and 50 grams of thallium. Make sense? So 2 half-lives. In 2 half-lives, how much time has gone by?
10 days.
10 days. So 10 days have gone by. And how much bismuth is left over? 25 grams. And how much thallium has been produced? 75 grams. All right. And we can continue on. In 20 days, how many half-lives have gone by?
4.
4. So 4 half-lives have gone by. And how much bismuth is left over?
12.5.
Is it 12.5?
6.25.
6.25. Because that 25 has divided, but that 15, so you basically say, we didn't write it in, but at 15 days, there was 12.5. There was 12.5 and 87.5.
Yeah.
Does that make sense? So in 4 half-lives, in 20 days, there's 6.25 grams of bismuth and 93.75 grams of thallium. Capiche? Okay, if this makes sense to you, give me a thumbs up. Or give me a pencil up. If you want to talk about that again, wave your hand around. Okay, so we basically divide it and divide it and divide it and divide it. Now, there are math formulas that we can use, but why? So in 1 half-life, that's 5 days, it's split once. In 2 half-lives, which is 10 days, it's split twice. And in 4 half-lives, which is 20 days, it has split 4 times. So 100, 50, 25, 12 and a half, 6.25. So if I didn't ask you for the 3 half-lives, which is what the 15 days would have been, it would have been 12 and a half and 87.5. But it's split again a 4th time. So after 20 days, 6.25 grams of the original stuff was left over, and the remainder was the new stuff. Am I getting across now? We're good?
Yeah.
All right. So next, 25 days. So how many half-lives is 25 days? 5 half-lives. And how much bismuth is left over? 3.13.
25.
Yeah, we're just gonna stick with the 3. We're gonna round to 3 numbers. So that means there is 96.87 grams of thallium. Does that make sense? So does this chart make sense?
No.
No. Okay. You want the formula. Okay, I will show you the formula later. So the best way to do half-life, in my opinion, at this level, the best way to do half-life is say, how many times does it split? Okay, so if it splits once, 50 becomes 25. Divide by 2. So divide by 2 every time you reach a half-life. The first half-life is 5 days. Divide by 2 once. The second half-life is 10 days. Divide by 2 twice. The third half-life is 15 days. Divide by 2 3 times. The fourth half-life is 20 days. Divide by 2 4 times. If you want, the formula is this. 1/2 raised to the number of half-lives. Okay. That's the magic formula. So if you're like, all right, in 1 half-life, that's 1/2 raised to the first power, that's you have half your stuff. In 2 half-lives, that's 1/2 raised to the second power, you have 1/4 of your stuff. Make sense so far?
Mm-hmm.
In 3 half-lives, that's 1/2 raised to the third power, you have 1/8 of your stuff. And in 4 half-lives, raised to the fourth power, you have 1/16 of your stuff. Yes?
What do you mean by stuff?
Of the original 100 grams. Of your original 100 grams. divided by 16. 1 divided by 16. 6.25. Oh yeah, so 1 divided by 16 is 0.0625 times 100, so 6.25. And then I go 1 divided by 32, it's 3.125. Make sense? So if you want to use the formula, great, here's the formula. If you want to make a chart, great, here's the chart. Okay. 23 days. Things get a little weird, 23 days. You know that 23 days is going to be somewhere in here. So you can say, all right, I know it's going to be somewhere between 3 and 6. It's going to be about 5 grams and 95 grams. Okay. If you want to eyeball it and estimate, I'm all for it. If you want to use the formula, then you have to figure out how many half-lives you have. Does that make sense? So 23 days is 23 divided by 5, that's 4 point something something. So 23 divided by 5 is 4.6 half-lives. So you go 1/2 raised to the 4.6 power. Assuming your calculator will allow you to do that. Some don't. Some like, I'm not going to raise it to a partial power, ain't gonna happen. Let's see if this one can do it. 0.5 raised to the 4.6 power. 4.123. So officially it is 4.12 grams and 95.88 grams. Not all calculators can do can do those weird irregular exponents. Does that idea make sense? So that's the bulk of half-life. The idea is every half-life has a certain amount of time. And every time you go through a half-life, you split your original mass by 2. Now, I made it easy for the first example. We used 100 grams. But it might not be 100 grams. It might be 3 grams, then 1.5 grams, then 0.75 grams, and so on. Are you getting this? Okay. If you understand this and are ready to move on, give me a thumbs up. If you want to talk about it again, wave your hand around. Okay. All right, so this is what the graph would look like. So 0.5 raised to the number of half-life power. And again, if you like formulas, if you don't know what the actual number of half-lives is, you take the time divided by the half-lives, and that's how much you have. So original mass times whatever it happens to be, 0.5 raised to the, and it looks like this, 50. There's some really great videos on half-life if you got a chance to watch it. Okay, some practice. The half-life of Cobalt-60 is 5 years. If you have 10 grams of Cobalt-60, how much do you have after 15 years? So this is for you, of course. So good. Troy, I like where your mind's at. So go ahead and work on these. When you're ready, we'll come back together and talk about it. And by talk about it, I mean choose military volunteers to put their work on the board. The aqua cells are made of crazy little crystals.
You see how many grams are left in here? I split each half. So in 15 years, it's 3 half. So you split 10.
And then you times it by 10.
Yes.
How do you know to put like under the like on that you put volume?
Oh, we don't know yet. We don't. Yeah, we don't know. We don't know what the daughter nuclide is in this case.
Half-life of an element. I mean, it's like split. And after 15 years, that's 3 half-lives. That's 10 to 5, 5 to 2.5, 2.5.
Who's going to be our lucky volunteer? I swear it's totally random. I swear. But Sunshine, you're first again. You're just lucky apparently.
I know.
Yeah. Oh, they're right there. Let me just spin this. Yeah, just a cobalt. We don't know what the daughter nuclide is. Okay, so we started with 10 grams. Thank you very much. With 1 half-life, that became 5. That was 5 years. With 2 half-lives, that became 2.5 in 10 years. And 3 half-lives is 15 years. So you can also say, all right, well, I know I got 0.5. I'm going to raise it to 3 half-lives and then multiply that by 10 grams. So chart, great. Math, great. If you agree with Sunshine's assessment, give me a thumbs up. Awesome. If you need a better explanation, raise your hand and wave it around. All right. Americium 242. This is a radioactive material you have in your smoke detectors. Has a half-life of 6 hours. If you start with 24 grams and now you have 3 grams, how much time has passed? Think this one through. You started with 24 grams and now you have only 3 grams. How much time has passed? Oh, that's just unsettling. Plus, apparently these only come in small face models. I have a large face. I need an extra large. Maybe like a 10, perhaps. you're still scribbling. Give you another second to scribble. Again, you can choose your favorite mechanism. Make a table, you can do math. Entirely up to you.
Oh, wait, no.
Okay. Our next volunteer. Okay, that's enough. Oh.
Yes.
Okay.
Yes. No, sway.
I'm going to reshuffle.
So much space.
One's not here, and the other two actually went last time. Shuffling again. This has got to be better. Okay. And cut. And it is Stella. Did you go last time too?
No, I
Oh. Okay. So let's break this down. Thank you. So let's break this down. We got 24 grams. And we're starting at 24. After one half-life, we got 12. That's one half-life. After two half-lives, we got 6. And 3 half-lives, we got 3. So does 3 half-lives make sense? And if each half-life is 6 hours, then 3 times 6 is usually 18. Make sense? Okay. If you're happy with that explanation and still his answer, give me a thumbs up. If you'd like a better explanation, raise your hand or wave it around. All right, let's try one more. iodine-131 has a half-life of 8 days. If you have 8 grams of iodine-131 and 16 days pass, how much iodine-131 do you have left? One more. Get it one more. All right. And our next contestant is Carter. Okay, So half-life is 8 days, 16 days pass, that's 2 half-lives. So if you have 2 half-lives, you're gonna start at 8 grams. So 8 grams at 0 half-lives, 4 grams at 1 half-life, and 2 grams at 2 half-lives. Sound good? All right, one more. Then I believe you are off to the races after this one. Let me see. Atomic stability, yep, that's tomorrow, or it's Monday, Tuesday. Tin! Tin 126 is a half-life of 100,000 years. If you have 7.8 grams left of a 250 gram sample, how much time has passed?
This is too many big numbers.
Yeah, this is very nice.
I'm angry at numbers. Why? There's too many of them.
Exactly.
Oh wait, I got it first try. No way. There you go. I just put in a random number. Look at these numbers.
Look at you go.
About 5. Because it's half line so therefore it's not as big as these.
Okay. Evan, you are our final contestant of the day.
He's guilty.
Okay. So let's see. 250 grams, 125 grams, that's 0 half-lives, 1 half-life, 68 grams, we just go ahead and go with 68 grams, is 2 half-lives, 34 grams is 3 half-lives, 17 grams ish is 4 half-lives, and about 7.5 grams would be 5 half-lives. Ish. So yeah, so 5 half-lives, 100,000 years, a half-life, about half a million years. Make sense?
I don't know.
Awesome, 5 for 5, okay. So, there is an assignment online, it says half-life practice exercises. You can use the remainder of time to work on that. If you need any help, let me know. Other than that, off you go.